If we want to talk about adding two vectors, we can't really add them the same way that we add numbers. At least, we can't add two-dimensional vectors in the same way that we add one-dimensional numbers. So in this video, we'll go over some geometric ways of working with vectors. The first thing we want to figure out is how to add two vectors geometrically. Maybe it's not completely obvious how we do that. For instance, take a few seconds to imagine, how exactly would we add two vectors? In order to add them, all we have to do is take the tail of one vector and snap it onto the tip of the other vector. What we're left with is this chain of vectors, and the tail of the first vector is the starting point of the resultant vector, and the tip of the last vector is the ending point of the resultant vector. The resultant vector is what we get when we add these two vectors here. So that's interesting. But what if we had gone the other way around? What if instead of adding the second vector to the first vector, we added the first vector to the second vector? Well, in order to add these two vectors, all we have to do is place the tail of this vector at the tip of the other vector. And now again they make this chain of vectors, so the tail of the first vector connecting to the tip of the second vector gives us the resultant vector. And hey, look at that! It turns out that adding two vectors, or any number of vectors for that matter, does not depend on the order we add them in. We can add them in any order we want. That's a nice fact to have. Now you know how to add vectors geometrically, but suppose we want to talk about what the negative of a vector looks like. Suppose we have this vector here, let's call it a. If we want negative a, all we have to do is twist a around so that it's parallel to the original vector, but going in the opposite direction. We call this antiparallel in the lingo. Two vectors are antiparallel if they're parallel, but point in opposite directions. So if a was given by that first vector, then this vector we have now, the antiparallel version of a, is equal to negative a. Now let's move on to how we go about subtracting two vectors. I propose to you that we actually already know how to do this. We already know how to subtract two vectors. Let's look at this example. If we wanted a minus b, we could try to think about it from a different perspective. For example, we know 3 minus 5 is equal to negative 2, but we also know that 3 plus negative 5 is equal to negative 2. If we have two numbers, a and b, we know that if a minus b equals c, then a plus negative b is also equal to c. We can actually apply the same logic to vector subtraction. So instead of framing vector subtraction how we originally did, why don't we think of a minus b instead as a plus negative b? And now we have something that we can actually solve. We know how to add two vectors, and we know how to take the negative of a vector. So all we have to do is take the negative of b, which we know how to do. We just imagine the antiparallel version of b, and that's negative b. And then we take that and add it to a. We're essentially adding negative b to a, which is the same as doing a minus b. So really we have just gone through the seemingly convoluted way of subtracting vectors and framed it instead as doing a plus a negative vector. So if you ever want to subtract vectors geometrically, that's all you have to do. Just add the negative of whatever vector you want to subtract. We have one last thing to cover in this video, and that's how do we multiply a vector by a scalar, or by a number. Notice here that we're not talking about multiplying a vector by a vector. That's a whole different beast, and we will cover that eventually. But for now, we're only talking about multiplying a vector by a scalar. If we have some vector and we want to multiply it by some scalar, maybe 3 for example, all we have to do is take this vector and scale it up so that it's 3 times its original magnitude. And that's all there is to it. So if you want to multiply a vector by say 1/2, you just scale the vector down until it's half of what its original length was. What if I want to multiply a vector by negative 5? Well, we can think of this as two operations actually. One is taking the negative of the vector, and the other is scaling it up by a factor of 5. And you can actually do these two operations in whatever order you want. 5 times negative a is the same as negative 5 times a. So that covers all I wanted to talk about with respect to geometric vector algebra. In the next video, we'll take a look at geometric vector algebra's ugly cousin, numerical vector algebra.